All right, so for the final two formulas, or solids, which is a sphere and hemisphere, I need you to understand that in all four of these formulas, you're going to see pi r squared show up someplace. The the cone has a circle base, the hemisphere a circle base, the cylinder also a circle base. The sphere itself, actually, the circle is you slice the sphere in half and you look at that circle at the I'll call the equator, which is the same circle as the hemisphere. The previous discussion, the formula for a cylinder is pi r squared times h, where pi r squared is the number of cubes per layer. And then a cone is pi r squared times h again, which is the volume of the cylinder, and then we have to divide by 3 or multiply by a third. So in our video, what we're looking at is the relationship between these two shapes here. How many cones would you think if I fill these cones up with water would it take to fill up the sphere if both shapes have the same height and the circle of the cone is actually the circle at the center of the sphere, which again is the equator. Once you think about how many cones you think we need to fill up to equal the entire space of the sphere. Give you a moment to think about that. All right, so let's see if your estimate is correct. All right, so the answer is 2. So it took 2 cones to actually fill up the sphere. So keeping that in mind, since it took 2 cones, that means that the formula for a sphere would be doubling the 1/3, which would be 2/3 pi r squared h's. And the hemisphere actually, 1 cone actually filled up the hemisphere. So the cone and the hemisphere actually have the same volume if they have the same height and the same circle base. Now, if you look up these formulas, you're not going to see h anywhere because the sphere itself doesn't have a height, at least not the way we think of height. So I'm going to draw a sphere here, and the total height of the sphere goes from here to here through the center of the sphere. So that length there actually is a segment we talked about, and from here to here, which is actually part of the circle, that length from here to here is actually a radius, and same thing here. So that total length is actually a diameter, or 2 radii. So if you look up the formula for a sphere, for example, the h actually is replaced with 2r. The height actually is 2 radii, as it goes to the center of it. So if I multiply the 2 to the 2/3, because I'm doubling it, I end up with 4/3, and then pi, and then I have an r squared plus 1 additional r. So that means I have 3 r's altogether, going back to your algebra rules for exponents. So the final formula for a sphere is 4/3 pi r cubed, because we're replacing the H with 2R. And if I did the same thing in the hemisphere, the 2 times a third, which I'm doubling the 1/3, is going to be 2/3 pi times R. And again, I have 2 R's plus another R, so we're R cubed. So again, all four formulas have pi r squared. It's just that it doesn't look like it because we're replacing the H with a value of 2R. So onto the sphere. Find the volume of the sphere. It's 4/3 pi r cubed. So it'll be 4/3 times pi times 3 cubed. So if I take and put my calculator, 4/3 times 3 cubed, I'm going to end up with 36 pi. And again, if you were asked to use 3.14 for pi, then you'd have something close to 110 for this problem. The second problem, the volume of the sphere is 4/3 pi r cubed. Again, we're replacing the R with 7. So I take 7 cubed times 4 divided by 3. This one here, I end up with 457 point. The 3 actually repeating. So if I want to approximate, it would look like this: cubic centimeters. This is cubic feet. If I want to make a more accurate answer, the point 3 repeating is 1/3. So I could also write 457 1/3 pi cubic centimeters. You're going to find in the worksheet that you're asked to convert, change the pi over to 3.14, so you're going to be getting some kind of approximation. But again, it's 4/3 pi r cubed. In the hemisphere, the volume of the hemisphere is 2/3 pi r cubed. So 27 is being cubed. So 27 cubed times 2 divided by 3, we're going to get 13,122 pi cubic centimeters. And then for the other one, volume of the hemisphere, again, is 2/3 pi r cubed. So it's going to be 2/3 pi times 15 cubed. So 15 cubed times 2 divided by 3. Get 2,250 pi cubic inches. And again, if you were asked to turn it into a decimal number, you just replace the 3.14 pi with 3.14 and multiply it to both these numbers. So that's our last 2 rules. I'll go back to that last screen. And make sure you also included in your list hemisphere and sphere. Maybe include the fact that the hemisphere actually has the same volume as the cone, and the sphere is actually double the cone with the same base and height. So, in your remaining time, please complete the worksheets. Your our teacher will be passing out the third and final worksheet on sphere. And again, this is a reminder, all the worksheets are posted in the back of the room. The prism part and the cylinder part should already be finished, so you're finishing up the other 2 worksheets plus the sphere, which has, I think, 8 problems on it.